Assalamualaikum warahmatullahi wabarakatuh and very good morning. So today we are going to practice for chapter 5, part A, which is differential method. So remember again, in differential method, basically there are two methods under it. The first one would be graphical and the second one would be numerical method. So both are differential method. Okay, here we have one question. So we're going to study two questions, one representing the graphical method question, another will be numerical method. Okay, let's see the graphical method question. Chemical A, so we have one chemical, was decomposed. So here we have chemical A, it was decomposed in a constant volume batch reactor. So it's a batch reactor, where the following concentration measurements were recorded as a function of time. So here you have table 1 consists of time and its respective concentration of A over time. And we have 5 set of data. All right, so using graphical method, so the question basically we directly mention which method you have to use. Derive the rate law. So they ask us to derive the rate law for the reaction based on the provided experimental results. Please provide any assumptions made during the analysis. Okay, now we have highlighted actually what are the important information from the paragraph. The first one is it mentioned that A was decomposed. Since A was decomposed, we can say that chemical reaction equation is A to end products. Okay, we have only one reactant. So we can use the differential method because the idea is for differential method, we can only relate with one concentration. If you have two concentration, then you need to use method of excess. Since there's only one concentration, we have no such problem. All right, and then it highlighted we have to use graphical method. Okay, we know that. We have to make a histogram. Then we have to derive the rate law. So deriving the rate law. So the question wants us to derive the rate law. So how do we derive the rate law for only one chemical product? We know that the rate law is minus RA, the rate of disappearance of A is equals to KACA alpha. And in this case, our K is the specific rate constant and alpha is our order. So we don't know what is the value of K and also alpha. We have to solve it using the graphical differential method. So we write back the rate law, but this time in differential form. So we know that minus RA is equals to KACA alpha. And if we include the differential form, it becomes minus dCA over dt equals to KACA alpha. So we have a relationship between concentration and time, which was given in table 1. Okay. So in order for us to solve this, we have to change this rate equation into linear form to find the value of the constant, which is K and also alpha lah. So when we change to linear form, minus dCA over dt equals to KCA alpha, change into ln. So we introduce ln lah. Ln minus dCA over dt is equals to ln K plus alpha ln CA. For this derivation, I've already shown in the previous video, so you can always go back to that video to figure out how to actually change from the rate of equation, the rate law equation into the linear form of the rate law. Okay, so if we want to find K and alpha from this linear form, how can we get this value? Is by plotting a linear graph that relate ln minus dCA dt as y and also ln CA as the x-axis. From there, we can find our alpha from the slope and we can get ln K from the intercept. Okay, remember back I have explained in the previous video, the steps for graphical differential method, what do we do? Since we already get the data, the tabulated data of time and also concentration, what do we need to do is we have to convert those value into minus changes of concentration over changes of time. Why minus? Because later on we have to plot ln minus dca over dt. So the minus should be there. So once we calculate and tabulate minus changes of concentration over changes of time, we have to find the second step is to find minus dca over dt. To find minus dca over dt from minus changes of concentration over changes of time, we have to plot a histogram. Here you can see on the right, I show an example. So we have this graph. So you have to plot the graph. How do? You know the changes of concentration over changes of time. So that would be your y-axis, your x-axis will be time. So last time we showed already. So you plot the histogram. So plot changes of concentration over changes of time versus time, and then draw a smooth curve. If you see this purple color there, that's the smooth curve, okay, that connected all the histogram. Then you find minus dca over dt, which is the cross-section between the smooth curve, the purple smooth curve, with the vertical red histogram, okay? Then what do? Third step is to plot linear graph to solve the value of alpha and also k. So what do? You plot back the linear form of the rate law. So your y-axis will be ln minus dca over dt. You can see here ln minus dca over dt. And your x-axis will be ln ca. So here is your x-axis ln ca. So if you got a straight line, your slope will be alpha and the intercept will be ln k. So you can solve for alpha and also k. Once you solve it, remember back the question asked you to derive the rate law. That means you have to go to the final step where you have to rewrite the rate law using the solve value of alpha and also k. So that are basically the step involved to solve this question. So let's go to solve it. So the question I have given from table 1, the value of time and concentration. So here is our time and concentration. That will be our step A, is to find minus changes of concentration over changes of time. So you tabulate the data to ensure that no mistake. You find changes of time. That would be simply the second data minus the previous data. So 10 minus 0 will be 10, 20 minus 10 will be 10, and so on. Then you find changes of concentration. That will be 1.35 minus 2. Allah Akbar. That will be minus 0.65, and then you deduct 0.87 with 1.35. You'll get minus 0.48, and so on. So it is acceptable if the value is negative, since the concentration is reducing, it's decomposing. And then what do? You calculate changes of Ca over changes of T by simply minus 0.65, you divide by 10, you get the value, and then you have to change it into minus form. Don't forget, because later on you have to plot the graph of ln minus dca over dt versus ln ca. Okay, so you have already solved step 1. Now let's go to step 2, step D lah, where you have to find minus dca over dt. In order for you to find this minus dca over dt, we need to plot a histogram. Okay, so here is our histogram. We have plotted the blue color is our histogram. We have actually 5 set of data, hence we have 4 histogram. 1, 2, 3, and 4 histogram. So we plot minus changes of concentration over changes of time versus time. Then we draw a smooth curve. You can see here the purple color is a smooth curve that connected all the histogram. Then we can find minus dCA over dt in green color, where it is represented by the cross-section between the purple curve, the dotted purple curve, and also the vertical histogram line. So here we have at time equals to 10, this will be our minus dCA dt value. At time equals to 20, the green arrow shows the value of minus dCA over dt. At 30 minutes, here the green arrow shows the value of minus dCA over dt. So we tabulate it. Okay, we tabulate it. So which is actually involving step C. So this is the value that we got from the graph. This is the value that we got from the graph. So in order to proceed to step C, where we have to plot ln minus dCA over dt versus ln CA, beside having this minus dCA over dt, we prepare our x-axis and y-axis. So our x-axis will be ln CA. We simply can calculate from the concentration value, and then our ln minus dCA over dt that we get. Okay, we get the value of minus dCA over dt from the graph, then we calculate the ln value as the y-axis. So when we plot, so y-axis is ln minus dCA over dt, our x-axis is ln CA. From there, you can find the value of the slope and also intercept. In my case, since I use Excel, I directly get the value lah. But for you, what you can do is you can find the slope by simply calculating the difference in y-axis over the difference in the x-axis, and you can get the slope lah. And for the intercept, you can simply find the value at the intercept of your graph. Hence, we can go to the final step, step D, where you have to write the rate law. So we know that the rate law is minus RA is equals to KACA alpha. And from the graph in step C, we found that alpha, the order, is equals to 0.955, which is close to 1. And ln K, our intercept, is equals to minus 3.0222. Thus, K is equals to 0.05. As we can put back into the rate law, we get our rate law as minus RA is equals to 0.05 CA. So we have solved the question. Okay, so if you have any trouble, you can always relook back at the video and try to solve by yourself. Okay, we have finished the first question that covers differential method or graphical. All right, let's go to question 2. Okay, question 2 cover differential method, numerical. Okay, you can pause the video for a while and try to read the question for 1 minute, and then we can discuss. All right, let's say you have read. Let's read the question. So here what is the question? The reaction between penicillin G, or represented by P, and hydroxylamine and H2OH. So we have two reactants. Is carried out in a batch reactor according to the following stoichiometric equation to form hydroxamic acid. So this is our product lah. We have two reactants and we have one product. To determine the rate law, so you have to determine the rate law of this reaction. The concentration of penicillin G, the P, was intentionally kept in excess. So P is already in excess. After the end of each batch reaction, all samples were analyzed for the remaining concentration of hydroxylamine, that will be NH2OH. So this is the product that you evaluate lah. Table 1, the remaining concentration of hydroxylamine at the end of each batch reaction. So we have time here and we have concentration here. We have 6 sets of data. Using numerical method, so the question is very clear, you have to use numerical method, derive the rate law. So you have to write the rate law, which means the same thing. You need to find the parameter for the reaction based on the provided experimental results. Table 1. Please provide any assumptions made during the analysis. Okay, so now what do? Take your time, try to solve by yourself first if you can. If not, we can proceed to see the answer from the video. Okay, we have already highlighted the important step. Similar with question 1, we have to find the rate law parameter, but in this case, we have 2 reactant, 1 product. Additional info, penicillin G was intentionally kept in excess, it's already in excess. Okay, so if we rewrite the chemical reaction equation, this is the chemical reaction equation. Since P is in excess, then NH2OH is the limiting reactant. So we can rewrite it into NH2OH plus P to get your product. And we rewrite it in simplified equation. We can represent them as A plus B equals to C, where A is our limiting reactant. Since B is put in excess, the chemical reaction equation considered is A to produce product. So it has fulfilled the requirement to solve the question using differential method where there should only be one concentration evaluated. So no problem lah. So what does the question want? Similar, want us to derive the rate law since only focus on A. So we have minus RA is equals to KACA alpha. And then we have to find alpha and also K. Similar like previous question, if we write the rate law in differential form, that would be minus dCA over dt equals to KACA alpha. And in linear form, we add ln terms. So we got ln minus dCA over dt equals to ln K plus alpha ln Ca. So by plotting the graph of ln minus dCA over dt versus ln Ca, we can figure out what is alpha and also K. Alright, so for numerical formula, numerical method is very simple. We can simply use the equation. And to do that, we are given the data of time and also concentration here. So this is our concentration Ca in molar. So 250 at times 0, 42 at times 10, 21 at times 20 minutes, and so on until 7.5 at times 50. So what do? We can simply use the formula. There are only 3 formulas for us to solve using numerical method, which is the equation to solve the initial point, the equation to solve the intermediate points, all, and then the equation to solve the final point. Okay, so let's see. For us to find at time 0, our dCA over dt, this is not minus yet, this is in positive form. So it's in positive form. Our dCA over dt equals to minus 3 times Ca0, that will be 250, plus 4 times Ca1, that will be 42, minus Ca2, that will be 21, over 2 times changes of time, which is the difference of time. Here 10 minus 0 is 10. So remember back, for us to use this numerical method, the increment of the time should be uniform. So in our case, we have fulfilled the requirement lah, 0, 10, 20, and so on. So we solve for the initial point, we get dCA, the positive dCA over dt equals to minus 0.3015. So here in our table, we already write minus 0.3015, that should be not 3, 0, minus 0.3, blah, blah, blah. Okay. Then we solve for intermediate. Okay, so for intermediate, what do? When we want to find dCA over dt at point 10, for example, we will use concentration of the adjacent data. So here at time 10, dCA over dt is equals to 21, the adjacent, minus 250, another adjacent, over 2 times 10. 10 is the difference of time lah. Then we get the value. So this is our value. We do the same for every point. Okay, at point 20, it will be the difference between 15 minus 42 divided by 2 times 10. At point 30, we see the adjacent 10 minus 21 divided by 2 times 10. And then finally, for the intermediate, 40 it will be 7.4 minus 15 divided by 2 times 10. So we got already the intermediate value in positive dCA over dt form. Then for the final value, we're going to use another equation that would be dCA over dt equals to 15, which is, so we're going to find at this point, so we will use the 3 latest point lah. 15 minus 4 times 10. 10 will be this part times 40. And then plus 3 times 7.4. 7.4 at times 50 lah, the time that we are searching for. Over 2 times 10. 10 is the time, the difference in time. So we solve, we got equals to minus 0.14. So you have solved for dCA over dt. Then next step, what do? We have to plot the graph of ln minus dCA over dt versus ln CA. So you can calculate ln CA based on the CA value here. You can get ln minus dCA over dt from the value of dCA over dt here. Then what we do? We plot the graph. So your y-axis is ln minus dCA over dt. Your x-axis is ln CA. So if you plot using Excel, you directly get the equation. But if not, you can simply find the slope to get your order and then find your intercept from the graph. Okay, solving that, you will get your alpha is 2.84. And then ln k, the intercept, is equals to minus 0.9. This k is equals to 2697.28. Finishing the question, they ask us to derive the red law. You can simply put the parameter into the equation. So minus RA equals to K, 2697.28, CA, alpha 2.8. Now you have already answered the question. So it's as simple as that. As long as you know how to apply the equation, then basically it's very easy to solve. All right, that's all for today. Thank you very much and see you again in the next video. Assalamualaikum.